Hello everyone, this is Khairul Mahbub and today I'm going to present you my research paper GanitLLM Difficulty Aware Bengali Mathematical Reasoning through Curriculum-GRPO. To start with, why do we need GanitLLM? Current proprietary large language models are showing promising results in mathematical reasoning. However, most of the reasoning happens in English. Also, they reason using too many tokens. And in the current reinforcement learning based training recipes, we have a cold start problem as the low resource languages are underrepresented in the language models. So GanitLLM tries to tackle these problems for Bengali mathematical reasoning. If we look at the current multilingual landscape, some of the works are focusing solely on the final answer accuracy, and some work reveals if the intermediate reasoning is in English, it boosts performance. However, we want to reason even in English so that it is interpretable to the end user. And some of the work revealed that GRPO improves mathematical capability using Chinese language. But as Bangla is very limitedly represented in the language models, so this hinders improvement for Bengali language and Bengali reasoning and Bengali mathematical reasoning. So our goal is to propose a Bengali mathematical reasoning evaluation benchmark. We want to introduce a small Bengali mathematical reasoning model that can reason using fewer tokens. We want to propose an efficient reinforcement learning training recipe. Now we will look into the Ganit dataset construction pipeline. We started with around like 1.5 million data samples from the existing open source and the research community. In the first stage, we applied quality screening in those data samples. After that, we applied rule-based filtering. In the next stage, we applied deduplication so that we do not have any overlapping data samples. Next, we wanted to make sure we do not have any overlaps with the evaluation datasets as well. So that's why we employed decontamination. After that, what we did is we used a strong evaluator model to difficult tag our data samples. This gave us around 39K data samples, and we divided this into two splits, one of which is Ganit train and the other one which is represented as uniformly sampled. We actually intended to propose it as an evaluation benchmark. So as we divided our data samples in using difficulties, and we decided to give 4 difficulty buckets, that's easy, medium, hard and Olympiad. And then in the next step, we applied LLM filtering because we wanted to ensure our evaluation benchmark is consistent. So we asked 3 strong models like GPT-5, Mini, Gemini 2.5, Flash and Grok 4 fast to solve these problems. And we employed majority voting and cross-model validation to ensure consistency. This LLM filtering stage yielded us the Ganit dev split, which we propose as the evaluation benchmark, and we further divided the Ganit train split into 2 splits. One we call Ganit SFT and the other one we are calling Ganit RLVR. Now we will look into training Ganit LLM with Curriculum-GRPO. So we are proposing a novel training recipe to tackle the cold start problem. So we are actually proposing a 2-stage training pipeline. In the first stage, we are doing supervised fine-tuning on the Ganit SFT split. So in using this approach, we are teaching the language model to reason in Bengali. In the next stage, we are applying curriculum sampling. So we used the Ganit RLVR split so that we can order our training data by difficulty. And we designed our rewards using 3 components. One is format, another one is correctness, and then we rewarded to ensure 80% Bengali reasoning. So if we look into our experimental setup, we used Quen 3.6 billion, Quen 3 1.7 billion and Quen 3 4 billion as our baseline. For the training, we used for the supervised fine tuning, we used Gonit SFT speed, and for the GRPO training, we used Gonit RLVR, and we evaluated our model on Bengali MGSM and Bengali MS-VAM datasets. So if we look into the result of our GanitLLM model, we can see the GanitLLM is outperforming its base models both in accuracy, in fewer words, and the percentage of Bengali tokens. Now, why multi-stage training? So our results shows that when we apply supervised fine-tuning, mathematical reasoning improves, and when we apply CGRPO only, the mathematical accuracy improves. But combining both of them gave us the best of the both world, which we can see in the results. So if we now look into the impact of curriculum GRPO, we can see that particularly on the MS-VAM dataset, the GRPO actually stagnates at some point due to the cold start problem. But when we apply curriculum GRPO, which is we are actually, instead of randomly shuffling our data samples, we reveal the data samples in order. Like, first we want to teach the model to solve easy problems, then medium problems, then difficult problems, and then the Olympiad level problems. So now if we look at the limitations and future work for the paper, so our study actually is limited to single language, and we are relying on proxy signals. For example, we used Parset K metric to difficulty tag our data samples, and we used character percentage heuristics, which can penalize correct outputs due to mixing language. So to sum up, our contributions are threefold. We propose a rigorously filtered Bengali math dataset, and we propose a curriculum guided low resource reinforcement learning training recipe. And to the best of our knowledge, we are proposing the first Bengali mathematical reasoning, which outperforms models twice of its size. Thank you.